Hello students, welcome back to Madhvi's Java programming tutorials. In this video, I'll be explaining math class methods and how to use it. This is a library class. Let's see the contents: introduction and pub, absolute, square root, cube root, round, int, ceil, floor, max, min and random functions we discuss. The math class has number of functions, but we will be discussing only a few of them which are very important. This math class allows programmers to perform mathematical calculations and it is defined in java.lang package. We all know that java.lang package is imported automatically for any program we create, the programmer creates. And this math class is a final class. That means which cannot be inherited. I'll explain this in the Java program. Now, math class methods are static methods and invoked with the help of class name itself. Now, calling different member methods video lesson number 12 discusses all these things like how to call a static method. Link is given in the description box. Now, for example, absolute and power are two methods which are static. So, how do we call them? Class name dot method name followed by any parameters. So, math.abs, one parameter. Math.pub, within parenthesis, two parameters, and so on and so forth. You may visit this link to see all the math class methods. Now, pub and absolute. By looking at the definition or header only, we'll understand it's a static method, and instead of void, there is double. Double means it is returning a double value. So far, we have seen how to write methods with void keyword. In the next video, user-defined methods which will return some value. Now, if you see this, pub is a method which is taking two parameters and it is returning one double value. That means pub 2, 3. If I say 2 is the base, 3 is raised to the power of 2. So 2 raised to the power of 3 is mentioned. See the example. Math.pub 2, 3, which returns 2 raised to the power of 3 is 8.0. That is a double value. If you want an integer, use explicit conversion. Similarly, math.pub 2, minus 3 returns the value of 1 upon 2 raised to the power of 3. Then math.pub 3, 5 imaginary number. For example, math.square root of minus 25 is imaginary, because minus 5 into minus 5 is always plus 25. So we cannot find the square root of a negative number, which is an imaginary number. So if we send in such a imaginary number, the math.pub returns nan. Nan means not a number. Then math.pub can use characters also. Characters means it takes the Unicode value. 4, A. Unicode value of A is 97, which is a very big number in the exponential format. Then comes ABS. ABS is an overloaded method, that is polymorphism. The concept of polymorphism is explained in lesson number 4, Principles of Object-Oriented Programming. I'll give the link in the description box. Now, this overloaded method is written in 4 ways. Absolute, 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 absolute. Same name of method. Taking double float int long as parameters and returning the same data type respectively. But all these things take a negative or positive value, returns positive only. For example, math.abs minus 5 returns 5. Because minus 5 is integer, we are storing in an int C, or we can directly print also. Let's see the Java programs. Now let's understand what is a final class first of all. Final class of final. I cannot give a keyword final, it gives an error. So I have given final. Control K, no problems. Now void A1 system.out.println in A1. This behaves like a normal class even if you put final over here. And this is an instance method. So it will be available to instance. Let's execute this program and see first of all. Okay. And void A1 in A1. It is normally behaving when we execute this class, which is started with final keyword. But we said final class cannot be inherited. Inherited means open editor and see some class A extends final cannot be done, cannot inherit from final because it is a final class. So extends keyword cannot be used with final classes. Math class is a final class. That means we cannot inherit anything. No inheritance possible. Now coming on to Power ABS. We've declared 4 variables. A is equal to 3, B is equal to 2, C is equal to minus 5 and D is equal to character A. Here I am going to explain a new method system.out.printf, just like your C language. Okay, before that, demo of POW method, result of POW 3, 2, that is math.pow A, B 3, 2. Math.pow can be used in system.out.println instead of storing also. We can store as well as directly print. So result of POW 3, 2 method is plus math.pow A, B, which will return 3 raised to the power of 2 is 9.0. The second method is result of POW 2, 97. How do we know? B, D. B is 2, D is character A, Unicode is 97, which will give a big number, 2 raised to the power of 97. And then third one is result of POW 3, minus 5. That is 1 upon 3 raised to the power of 5. And math.pow A, C. A is 3, C is minus 5. It gives the answer. But it is a double value which gives 16 digits precision. Let's suppose we want to format it. Format the output and restrict the precision, that is decimal after decimal number of digits to 3 or 4 or 5. Then we use system.out.printf, whatever message you want to give. In the message only, percentage, comma, that means I am going to format it. 0.3f means I want 3 digits precision only of whatever is being printed here. What is it? Percentage, comma, how many number of digits in the precision? 0.4, 0.5, any number, 0.1, anything we can take. Then math.pow A, C. This answer, the digits of precision will be restricted to 3 digits. Here 16 digits, here 3 digits. The same function I am calling. 3, minus 5, math.pow A, C. Math.pow A, C. But this is formatted. Now system.out.println result of 3, 5i, imaginary number which I have discussed already. Math.pow A, that is 3, raised to the power of math.square root of minus 25 is imaginary number. So the answer will be nan. Coming on to absolute method, everybody knows math.abs minus 5 returns 5. Math.abs 5 also positive returns 5 only. Let's execute and see. Okay. Result of 3 raised to the power of 2 is 9.0. Result of 2 raised to the power of 97 is so big number, E29. Result of power of 3 comma minus 5, that is 1 upon 3 raised to the power of 5, is this big number with precision. I don't want this much precision. In that case, formatted output, printf statement we have seen. With 3 digits precision, that is 0.004 is displayed here. So this is printf statement in Java. This is only for printing purposes. Now result of pow 3 comma 5i, that is square root of minus 25, is nan. Then result of absolute minus 5 is 5. Absolute of 5 is 5. This is about pow method, absolute method, and formatted output. Now let's understand square root and cube root. We mostly know the square root and cube root methods, but usage is math.square root. Now this is a static method, and square root takes one parameter and returns a double value. So if I say math.square root 25, it returns 5.0. If we want only integer, we need explicit conversion. Then comes static double CBRT double again. That means CBRT is the method, double is a parameter, and returns the double value. So we use math.cbrt 125 returns 5.0 cube root. Then comes round and rint. So static int or long, round, float or double. This is an overloaded method again. So if you pass double value to the round method, it rounds off to the nearest long number. And if we pass a float number, 99.4 or something like that, which rounds off and returns integer number, nearest integer it returns. So double and float will be converted to long and int and rounds off. We know 99.5 below, it becomes 99. 99.5 onwards becomes 100. We know the round function. But here data types we are learning. Double becomes long, float becomes int. If at all you are printing directly, no problems. But if you want to store somewhere, then long and int is a very important thing to be remembered. Then static double rint double. It rounds the value passed as an argument and returns a double value. Round returns either long or int. Rint returns a double value. Let's see Java program. In this program, we will see one interesting formatting technique. For example, double A is equal to 99.6. B 99.3, float C is 9, floats, 2 float values, 2 double values, A, B, C, D. Now we want to understand that round a double value returns a long. We can directly print also, but we want to understand round double values, either 99.6, that is A, or 99.3, that is B, returns long. When we compile, it does not give any error, control K. But what if I use int here? Immediately it gives an error saying that loss of precision. So we need to understand that what the function is returning. So round function, if you pass double, long will be returned. But if I take long here, it doesn't create any problem here. Why? Because int is smaller than long, implicit conversion. So it can be stored in long also. Whereas the other case, it is a problem because a long number cannot be stored in int number. So that's why I have stored here. Otherwise, we can directly print rounded value of A, that is 99.6 is 100. That is stored in A1. B, 99.3 is just 99, rounding off. 99.3 becomes 99. 99.6 becomes 100. Here also the same thing. Here the difference is float values are returned as integers. Now very interesting thing here. Let's suppose in any program there is some number 1.1. Whenever you add 0.1 or 0.2, 0.5, something like that, immediately x being a double takes 16 digits precision. And the answer would be a very long number. How to format, I tell you after executing and showing you the output here. Control K and main. Okay. This we understood, rounded value 99.6 is 100, 99, 99, 100, 99. Look at this. I have 1.1 and added 0.1, 1.2 with a big precision it is giving. I just want to restrict it to 1.2. How do I do that? This is a simple technique, but I thought students must know this. That's why I'm explaining. Math.round, use the math.round function. Whatever there in x, that big long number, after adding 0.1 into 10. Then one decimal position goes to the left, divided by 10.0. That means I want the output in the 0.0 only. Then see the output. This is math.round. Whatever variable you feel that it is having so much big precision, multiplied. If you want only one digit, x into 10 divided by 10.0. If you want 2 digits precision, x into 100 by 100.0. 3 digits precision, x into 1000. In the previous one, system.out.printf only formats and prints. But here, math.round, this particular formula stores also. Control K and execute round. Okay. See, one digit only into 10 divided by 10.0 is giving 1.2. This is one more use of math.round. Then rint, rounded till integer. So it says rounded to integer, but it returns a double value. Rounds off, but double value. 99.6 becomes 100.0. 99.5 also becomes rounding off math.rint y, math.rint x, math.rint z. This is also 99.2 will give 99.0. Whereas round returns either long or integer. Here double only. Let's see seal and floor. Static double seal double. It returns a double value and takes a double value. As the function name suggests, ceil means greatest value, but it returns the closest but greater value. Closest but greater means, example, ceil of 99.4, close but greater is 100.0. From 99.1 to 99.9, ceil will return 100. But for 99.0, it returns 99.0 only. What did the definition say? It returns the closest value which is greater than or equivalent to the argument passed to it. Then, but ceil of minus 99 point something. Ceil means greater, we said. Minus 99.4 cannot become minus 100. Why? Because minus 100 is smaller than minus 99. So, ceil of minus 99.129 returns 99.0. Whereas floor is opposite to it. Floor means on the floor. So, static double, floor double takes a double parameter, returns a double value. It returns the closest value which is smaller than or equivalent to. So 99.4, see, floor of 99.4 would be 99, smaller value. 99.6 also 99 only, 0.0. But whereas minus 99.4, we need a smaller number than minus 99, which is equivalent to minus 100. Let's see a Java program. See here, we want to use that math.round after some time. I am starting a for loop here. I is 99.1 to 99.9. Every time 0.1 I am adding. So 99.2, 99.3, 99.4, 90, and so on and so forth. Ceil value of I, according to me, it should display 99.1, then 99.2, 3, 4, 5, 6, 7, 8, 9, 99.9. Ceil would be 100 only for all of the values. But I want to teach you math.round one more time, which we have learned in the previous method. That is round method. So if I execute this, what will happen? Let's see first of all, then we use math.round. Then floor method, you know 99.1 to 99.9, it gives the floor value 99.0 and here floor value minus 100. Okay, let's see. Control K. Here in this place, we will have a problem so that we want to use the I into 10 divided by 10.0 concept. Control K. Ceil and floor. Try to execute. Okay. Here if you see, ceil value of 99.1, which is I initially, is 100. Then we said plus 1. That is 0.1 is added. Immediately the double value of I is showing 16 digits precision, which I don't want. I want 99 point round off to 2, then 99.3 and so on and so forth. Anyway, ceil value will give you 100. That is no problem. So, we'll come to that part. Math.floor 99.1 is 99.0. 99.5 is also 99.0. Floor value. Floor. Okay. Close this and go back and make two changes. First of all, I am saying double x is equal to some x variable. Math.round I into 10, I was 0.1 added. That is 99.1 became 99.2 Actually, it is showing 99.19999. Into 10 divided by 10.0 will give me 99.2 rounded off and giving me only one digit after precision. If I say 100 and 100.0, 2 digits precision. This is the first change, and second change, I use X here because my output is no problem, but this X or I is giving me problem. So control K and seal and floor. Okay. See here, formatted output 99.1234 math.round has done the trick here. So this is how you can use in programs. Max and min we know, but there are 4 overloaded functions. Int max, int, static only. Integers, if you pass, it returns integer maximum out of 2 integers. 4 and 5, 5 is returned. Long also, double also, float also. 4.5, 4.9, it returns 4.9, and so on and so forth. And static min, there is a function called min also. 4 overloaded functions. Take 2 parameters, returns the same data type. If you send long numbers, they return long, double, float, int only. Then last but not least, random method. Static double random. Random method does not take any parameter and returns a double value. That too, between 0.0 to 1.0, 16 digits precision. Here also we can use multiplication operator to get one digit as an integer, because 0.0 to 1.0, one digit. In between that, if you multiply it by 100, then it can return 2 digits, that is 10 to 99, and so on and so forth. Let's see a program just for fun. Randomly generates some positive value between 0.0 and 1.0. Let's see the program. Now the random number generates automatically some number between 0.1 to 0.9 with 16 digits precision. Let's see a simple program which guesses some number. For example, scanner is taken, guess a number between 0 to 9 till it matches with the system generated number. We are running a while loop. User guess, we take the integer between 0 to 9 from user. And computer guess, we are using math.random into 10. That gives us 16 digit number. Now it has been converted to some 1 point, some 16 digits, or 2 point, or 3 point, something like that. We are taking integer part of it. So it guesses between 0.1 to 0.9 with 16 digits, but we are multiplying with 10. So the integer part will get 1 or 2 or 3, 4, 5, 6, 7, 8, 9. And I am taking an explicit conversion. That is only integer part. I want to discard the entire precision. Now, if user guess is equal to computer guess, then we say good guess, quitting, break. Otherwise, this program keeps running. Else, system guessed so and so, no match with your guess, again guess. Okay, control K, random numbers are generated with the help of math.random. Okay. Now, guess a number between 0 to 9 till it matches with the system generated number. Let's say we say 3. System guessed 8, so no match. 5, no. 3, no. 4, no. 6, 1. It keeps on guessing. Finally, I guessed 1 and the computer also guessed 1, so it is stopped. So this is about a random number. Refer chapter 6 of Basics in Computer Applications for further understanding and practice exercises. And the next video is about user-defined methods in Java. From now onwards, we will write proper programs. Thank you.